Hello gems, welcome back to another video. In this video we'll be discussing mock test 2 for JEE Mains 2023. In the previous video we discussed mock test 1, so if you missed that out, do check it out, links in the description. So there are no rules, you can do this first and then that. So let's begin with this one. Here we have question 1 and 2. In question 1 we have two statements A and R. A says that the time period of oscillation of a liquid drop depends on the surface tension, the density and the radius of the drop, and the relation is as given. And A says that this relation is dimensionally consistent. Okay, we are supposed to check that if A is true or not. And similarly R says that using dimension analysis will have the left hand and right hand sides of the dimensions to be different. Okay, so we are supposed to comment on A and R whether they are true or not. Okay, so let's begin with A. A says this relation is dimensionally consistent, so let's check that. Okay, so let's take dimensions on both the sides. So K is dimensionless, it is given, so we are only concerned about the dimensions of this quantities now. Okay, it is a square root, so raised to half. Then we have density. Density is mass per unit volume. Okay, ml to the power minus 3. Radius cube, so L cube. And then we have surface tension. Surface tension is force per unit length basically. So force is this, and per unit length L will get cancelled, mt to the power minus 2, and that to the power 3 by 2. Okay, so let's solve this now. So we have m and this will get cancelled, and in the denominator we have m to the power 3 by 2 and t to the power 2 and 2 will get cancelled and we'll have minus 3. Okay, and this whole is to the power half, square root, right? So this is m to the power 1 minus 3 by 2, that is minus half, right? This is 1 and this is 1.5, so it is minus half, and we have t to the power 3 in the numerator, right? Now if you solve this, we'll get m to the power minus 1/4 and t to the power 3 by 2. Okay, so if you see, these are not equal to the dimensions of time, which means that your A is incorrect. It says that your this relation is dimensionally consistent, whereas it is not, right? The dimensions on left hand side, which are the dimensions of time, is not equal to the dimensions on right hand side. Okay, so this equation is not dimensionally consistent, which means A is false. Okay, so A is false and R will be true, of course. If you see, R is just the implication of A, right? Since A is false, R is true. Okay, R, if you see, is using dimensional analysis. RHS has different dimensions. Of course, RHS has different dimensions, and you can use dimensional analysis to find that exact relation. Okay, you can use this time period depends on surface tension, this, and you can derive the exact relation. However, this relation is not true. Here the dimensions on both the sides are not equal, which means A is false, of course. And why is A false? Because the dimensions on both the sides are not equal. Okay, so option D is the correct choice over here. Let's come to question 2. It's very simple. We are given t in terms of x, okay, t in terms of displacement or distance. Okay, you are supposed to find dx by dt at t is equal to 4, dx by dt when t is equal to 4. Okay, so first of all, let's write it in terms of x. Okay, so we'll take 4 to the other side, so we have t minus 4 is root x, square it on both the sides, t minus 4 the whole square is x, right? So x will be, use the a minus b the whole square, so t square minus 2t, which means 2 into 4 into t, so which is 8t, plus 4 square, which is 16. Now take dx by dt. Okay, very important that you take dx by dt first and then substitute t is equal to 4. Okay, so dx by dt first, so 2t minus 8 here, the derivative clearly, and 16, that is 0. So now dx by dt at t is equal to 4. Substitute t is equal to 4, and what is the answer that you get? 2 4s are 8, minus 8, that is 0. Right, so option B, 0, is the correct choice over here. Over to the next question. Question 3 and 4 over here. In question 3, we are going to throw a ball vertically upwards with some velocity. Okay, let us suppose that velocity is u, it reaches a maximum height of h. Okay, suppose this is the maximum height h. Okay, so find the ratio of the time in which it is at height h by 3. Okay, so at 2 points in its journey it is going to be at height h by 3, one while going up and the other while coming down. You are supposed to find the ratio of the time periods. Okay, so suppose this is the point h by 3. Okay, so while going up it will take time t1 suppose, and while coming down, okay, this is the entire time taken, okay, till reaching h by 3. Okay, so these are the ratio. Okay, so you are supposed to tell the ratio of t1 by t2. Okay, so this ratio you are supposed to tell when the object is at height h by 3. Okay, it's actually a very typical question. You are just supposed to solve s is equal to ut plus half at square. Okay, you can see that this is a quadratic in time, right? T square t and a constant. Okay, so you will get the two time periods. You are just supposed to substitute s is equal to h by 3 and g value and all, and then solve this. So you will get t1 and t2. There will be two values of time, right? T1 and t2. T1 will be for this, okay, the shorter time period, and t2 will be this. Okay, so that's the way of doing it. Okay, so s is h by 3. This distance is h by 3, as we know. So we'll take the upward direction to be positive. Initial velocity u in the upward direction. A is minus g. Okay, A is minus g. So minus half g t square. Okay. Now we know that h is the maximum height. How is the maximum height given? Maximum height is given as u square by 2g. Okay, this is directly derived from v square is equal to u square plus 2as. You just substitute v is equal to 0. Okay, final velocity is 0. At the maximum height, final velocity is 0. So from there you can find the maximum height. So you will obtain that the maximum height is given by this relation, u square by 2g. Okay, for an object thrown with a velocity u in the upward direction, the maximum height achieved is this. Okay, so let's come back. So we'll substitute this because we want everything in terms of u. Okay, we'll keep everything in terms of u. So we can write h as u square by 2g, which will make it 6g. Okay, and this is ut minus half 6 half gt square. So let's write it as half gt square like a quadratic, minus ut plus u square by 6g is equal to 0. Okay, so this is our quadratic that we got, and now let's make the coefficient 1, so t square, and we'll multiply 2 by g, right? So this will become 2u by g into t, and we'll have again multiply 2 by g. Okay, we are multiplying each term by 2 by g, so this will become g square and 3, right? 2 will cancel 6 as 3, so u square by 3g square. Okay, so this is the quadratic that we get. Now we'll solve it. Okay, we'll solve it. So after solving this quadratic, we'll get t1 and t2. Right, that was the simple approach. Okay, so let's solve it now. Okay, so t will be given as, just use the quadratic formula, minus b. So minus b will make it 2u by g plus or minus under root of b square, so 4u square by g square, minus 4ac, 4 into a is 1 and c is this entire thing, u square by 3g square, right, both positive, yep, and divided by 2 times of a is 1. Okay, so 2u by g, we can take common over here, 4u square by g square. Okay, this can be taken common, 1 minus 1/3 will be left over here, right? 4u square by g square is taken common, and here we will have 2. Okay, so again we can bring this out of the root sign, 4u square by g square. So 4 square root of that is 2, u square is u, g square is g. Okay, so this 2 can be cancelled out throughout. Now we have two time periods, right, plus and minus. Okay, so plus 1 will be the higher time period, plus 1 will be the t2 time period, and minus 1 will be the smaller time period, which is the t1 time period going up, and t2 will be the coming down, right? So t1 will be the smaller time period, which is with the minus sign. Okay, so we'll get u by g minus u by g into here we'll have 1 minus 1/3 is root 2 by 3, right? 2/3. 1 minus 1/3 is 2/3, and T2 will be given as u by g plus u by g. Okay, here plus sign for T2, bigger time period. Okay, and again in the square root we have 2 by 3. Okay, now we'll simplify that further. We can take u by g common. Okay, so let's simplify that. I hope you are following it. Okay, so T1, let's take u by g common. Now it's pretty simple, straightforward. So it will be 1 minus under root 2 by 3. So we can take the LCM directly. So it will be root 3 minus root 2. Okay, you can see the answer now, divided by root 3. Okay, and for the other one it will be root 3 plus u by g common. Here we will have 1 plus root 2 by 3 for T2. So here the LCM will become root 3 plus root 2 divided by root 3. Okay, this is what we'll get. Okay, and when you take the ratio T1 by T2, okay, T1 is the going up time period, T2 is the coming down. So when you take the ratio, this and this will cancel, root 3 gets cancelled. So root 3 minus root 2 upon root 3 plus root 2 is what we get. Okay, which is option B. Okay, pretty typical question. You are just supposed to solve s is equal to ut plus half et square. Okay, and remember we will keep everything in terms of u. Okay, let's come to this one. We have a smooth circular groove. Okay, so just like a rim of a tire, in that rim you are going to move a block with some linear velocity v as shown. Okay, so you are going to move it so that it slides around the surface of the ring. Okay, so you are supposed to tell which of the following correctly represents the plot of normal force on the block. There will be some normal force on the block, right? Since it is sliding on the rim, so there is contact and there will be some normal force towards the center, I shall say, on the block, right? On the block due to the wall and the speed of the block. So you are supposed to tell the correct plot between the normal force and the velocity or the speed of the block. Okay, now the normal force will balance your centrifugal force, right? So you are moving the block around the rim, so it is so if you go on to the frame of the block, it will be putting some centrifugal force on the rim, right? So that force will be given as mv square by r. Okay, mr omega square, or if you want to write it in terms of linear velocity, it is mv square by r. So your normal force will be a result or will be equal to the centripetal force. Okay, so this normal force, you can see that m and r are constants. The radius of this rim is constant, also the mass of the block is constant, right? So n is directly proportional to v square. Okay, this is a happy parabola. If you can make out, y is proportional to x square. So this is a parabola, happy parabola. Okay, so this is the correct representation of it, happy parabola, y is equal to x square. Okay, so it won't be linear, neither what was this should be constant. Okay, so it won't be constant, it is a happy parabola, y is proportional to x square, y is equal to x square on face. Yeah, so let's move to the next question. And 6 over here. In question 5, we are going to project a ball at an angle of 60 degree with respect to the horizontal. The kinetic energy at the time of projection is E. You are supposed to tell what is the kinetic energy of the ball at the highest point of the flight. Okay, so is it E by 2, life of average YouTuber, E by 4, or E? Okay, so let's find out. Okay, so here we have the projectile motion at an angle of 60 degree. Here the kinetic energy is E. Okay, suppose the velocity be u. Okay, initial velocity of projection. Okay, so you can split it into component u cos 60 and u sin 60, right? So here what happens in projectile motion stays in projectile motion. No, so what happens in projectile motion is that this u sin theta component will keep on decreasing, right? As your ball is going up, u sin theta will keep on decreasing, and at the highest point the vertical component is 0, right? That's why it's not going up, right? The vertical component of the velocity becomes 0, and that is the maximum height, right? It cannot go further up. Okay, so only the component that survives is your horizontal component, which is u cos 60 in this case. Okay, so here the initial kinetic energy, you can make it out, it's half m into u square, right? U is the initial velocity. Here for kinetic energy we are just concerned with the speed, and here the energy will be half m into velocity square, which is u cos 60 the whole square. Okay, so what is the answer that we get? M u square, and cos 60, sin 30 is half, cos 60 is half, so cos 60 half, and that also squared, right? Squared. Okay, so that will become 1/4, right? So 1/4, and if you see this, this is nothing but E, right? So this is E by 4. Okay, it's E by 4. So option C, E by 4 is the correct choice over here. Let's come to this one. Here we have two bodies of mass 1 kg and 3 kgs. Their position vectors are given. You are supposed to tell the magnitude of the position vector, okay, of the center of mass matches with the magnitude of which of the vector. Okay, so first of all, let us find out the magnitude or the position vector of the center of mass. Okay, that is what we are directed to in this question. So position vector of center of mass will be the simple formula m1 r1 plus m2 r2 upon m1 plus m2, right? So m1 is 1 kg, 1 into the position vector of that. Okay, so that is I cap plus 2j cap. So 1 into this, the same vector, plus 3 times this vector. Okay, 3 times minus 3 I cap plus 2j cap, right? Minus 2j cap plus k cap. Now that divided by 3 plus 1, which is 4. Okay, now this will become what? So I cap plus 2j cap plus k cap, simplify that, minus 9 I cap minus 6 j cap and plus 3 k cap. Okay, and that divided by 4. Now subtract this, minus 8 I cap here, and this is minus 4 j cap, and this will plus 4 k cap. Okay, now divide that by 4. Okay, so that will be minus 2 I cap plus j cap, sorry, minus j cap plus k cap. Okay, now don't look at the options and say none of this match this and get confused. Okay, you are supposed to tell the magnitude of the position vector of center of mass, okay, which will match with the magnitude of any of this given vector. Okay, so you are supposed to find the magnitude of this, find the magnitude of all this, and see to what vector it matches. Okay, so if you see the coefficients are 2, 1 and 1. So where are the coefficients 2, 1 and 1? Here it is 2, 1, 2. Here if you see it is 2, 1, 2, 1 and 1. Okay, so basically the magnitude only depends on the coefficient, right? It does not depend on the sign. So you are basically squaring it. 4 square plus minus 1 square, so that is 1, and that is 1 square. Okay, so root 6, and here also 1 square plus 2 square 4 plus 1 square 1, so again that is root 6. Okay, so option A is correct over here. Let's move to the next set of questions. Question 7 and 8 over here. In question 7, the length of a wire is made double and the radius is made half of its initial value. You are supposed to tell what will happen to the Young's modulus. It gets old, lame. Okay, so what happens to the Young's modulus? Basically, Young's modulus is the property of a material. It does not depend on the dimensions, so it will remain the same. Okay, or if you want to take it this way, Young's modulus is the ratio of stress by strain, right? So if you change the dimensions, which means you are changing the strain, the stress will change accordingly, so that this ratio is maintained the same. Okay, so Young's modulus does not depend upon the dimensions. So remember that Young's modulus is the property of a material, it's fundamental property. So even if you change the dimensions, it will remain the same. Even if you change the stress, okay, so if you change the stress, if you apply 2 times the initial load, okay, the strain will adjust so that the ratio remains the same. Okay, so Young's modulus is a very fundamental property. It does not depend on the dimensions or the load applied. Okay, let's come to 8th one. Here we have 2 metallic conductors which we are going to connect in series. Okay, they have identical dimensions, so length and their area is the same. Okay, so they are like this. Okay, but their conductivities are different, sigma 1 and sigma 2. Length is the same, L. I didn't draw it properly, but understand that the lengths are the same and the dimensions are the same, length and area is same, conductivities are different. Okay, you are supposed to find the effective conductivity. Okay, so we can replace this, okay, these two metallic wires in series with effective conductor which will have the same area, but the length will be twice of them. Okay, and the conductivity will be sigma. Okay, so basically I am replacing this with another effective circuit, okay, which has conductivity sigma, length will be 2L, L plus L, okay, and area will be same as this. Okay, so R thermal over here, okay, so since this is a series combination, it will be R1 plus R2. What is the formula for R thermal? Thermal is L by Ka, right, or L by sigma h, since they are using sigma over here for conductivity. Where does this come from? Okay, I'll show you. It is Q by T, rate of heat flow for conduction is given as K A delta L by L, right? You can write this as heat current, thermal current, and this is delta L, and you can write this as L by Ka, right? This is nothing but this can be compared to I thermal as V thermal upon R thermal, right? This is delta V and this is R thermal, the resistance, L by Ka, L by sigma I. Okay, now let's substitute that. So on the left hand side, R thermal is the effective resistance, right? This is the effective thermal resistance. So effective one, we can take this one, right? And for R1, R2, these two wires we can take. So effective one, we have the length 2L, right? Length upon sigma, conductivity and area. For R1, we'll have L1 upon sigma 1 A1. L and A are same, so that's why I'm not writing subscript. Here for R2, we'll have L2, A2 and sigma 2, right? So now take common, whatever is common. So here we'll have 2, here L by A will keep separate, okay, so that it will cancel out. You can see that on the other side we'll have like this. Okay, we are taking L by A common, so this and this will get cancelled. So finally we have 2 by sigma, as take the LCM, sigma 1, sigma 2 plus sigma 1, or I can write it as sigma 1 plus sigma 2. So what will be sigma? Sigma is what we are supposed to find in our question, the effective conductivity, right? So sigma will be basically given as 2 sigma 1 sigma 2, okay, upon sigma 1 sigma 2, okay, which is option B, right? 2 sigma 1 sigma 2 upon sigma 1 plus sigma 2. Okay, so that's from question 8. Let's move to the next set of questions. Question 9 and 10 over here. In question 9, we have an alternate EMF given by that is applied to a circuit which has an inductor of inductance this Henry, and if an AC ammeter is connected to this circuit, you are supposed to tell what is the reading on this ammeter. Okay, so basically the reading on the ammeter will be the RMS current, right? Your ammeter, AC ammeters measure the RMS value. Okay, that's why RMS is of significance to us. Okay, so it will be V RMS upon the impedance of the circuit. Here we only have the inductor, so I can write it as XL. Okay, V RMS upon XL. Now how to find XL? XL will be omega L. Now what is omega? Omega, you can find it by comparing this equation, sine 100 pi t with A sine omega t, right? Omega here, if you compare, it's simply, here I shall write E naught. Okay, so omega, if you compare, it is 100 pi. Okay, so omega is 100 pi when you compare, and L is given to be root 2 pi pi, root 2 by pi. Okay, so this and this will get cancelled, and this is 100 root 2. Okay, now VRMS will be simply this value. This is the peak value, right? 440 is the peak value by root 2. Okay, peak value by root 2 is your RMS value, right? So 440 by root 2, and what is XL? XL is 100 root 2. So root 2 will become 2. Okay, so it is 44 by, I shall say 20. So you can divide by 2, that is 22 by 10 or 2.2. Okay, so 2.2 amperes. Where is that? Option C. 2.2 amperes is the correct choice over here. Let's come to this one. We are given on the left hand side, we are supposed to match the column. Okay, left hand side we have the different waves, and on the right hand side we have the applications. We are supposed to match the waves with their corresponding application. Okay, now it's pretty simple. If you see X-ray, okay, I'm going by the intuition of the most appealing one. X-ray is used for medical diagnosis, right? For scanning, internal scanning, okay, and fractures and all. So X-ray is used for medical diagnosis. Okay, so B is for 1, B1, B1. Otherwise, these options we can eliminate. Okay, so if you know the least amount, you can use this knowledge now. Okay, so now your chances are 1 in 50. Okay, 1 in 50, 50% I mean. Okay, so now UV rays, if you don't know, they are used in water purification. Okay, you might have heard in the advertisements of Kent RO and all, RO UV they say, right? So UV radiations are used in purification of water. Basically they kill the bacteria. Okay, so that's why they are used. So tell me the full form of RO in the comment section. It's not related to your course, maybe it is, but it is a part of chemistry. Do let me know the answers in the comment section. I will pin your comment if you give me the correct answer. What you thought? Giveaway? No. Okay, so yeah. So do let me know what is RO. So UV are used for water purification. So A is for 2. So A is for 2. Okay, so you could have directly guessed out the answer from this. Okay, you don't have to know about these two things, but still I'll tell you that microwave is it's correctly matched with communication. So microwave, if you see, it's very close to radio, right? Radios are used for communication, right? So it's high wavelength frequencies, high wavelengths that are used for majorly communication. Okay, so microwave is also used in communication. Okay, infrared is for visibility in fog. Okay, I also didn't knew this, but I know it now, and you should remember it too. Okay, might come up in your JEE paper. Okay, so correctly matched. This is for water purification, this is for medical diagnosis, this is communication, and D is for visibility. Okay, so here what is wrong? Here A is wrong. Okay, so yeah, so option B is correct. Let's move to the next set of questions. 11 and 12 over here. Question 11, we are supposed to find the ratio of the energies for the transition of an electron in hydrogen atom. So the ratio is between the transition for the energy from the second permitted level to the first. So this is one energy level, and the second energy is from the highest permitted energy level to the first. Okay, these are two energies related with the radiation due to the electron. So you are supposed to find the ratio of their energies. Okay, now the formula that we are supposed to use is 1 upon lambda r 1 minus n final square minus n initial square. Okay, so 1 upon lambda, you can see that it is proportional to energy, right? Energy is hc by lambda, so 1 upon lambda is proportional to energy. Okay, so I can say E1 is proportional to 1 upon lambda 1. Lambda 1 is for this transition, okay, from second permitted level. So n final over here is 1, and initial second permitted level. So initially it's in the second level, it will come to the first. Okay, so initial is second, final is 1, initial is second, so second squared, so which is 4. Okay, so 1 minus 1/4 is 3/4, so we have 3r by 4. So E1 is proportional to 3r by 4. So E2 similarly is proportional to 1 by lambda 2. For lambda 2 we have the transition, finally it's the first state. Okay, it's from infinity to the first state, highest permitted level, which is infinity. So 1 upon infinity square, which is 0. So basically this term is 0, and here we have r. Okay, so E2 is proportional to r, so their ratio E1 by E2 will be proportional to, take this ratio, 3r by 4 times r, 1 upon r, right? E2 is proportional to r, this is proportional to this. Okay, there will be some constant. When you take the ratio, it will get cancelled, right? R and r will get cancelled. 3:4, option A. Let's come to this one. We have a traveling microscope. So this question is based on the concept of vernier caliper. Okay, So you are supposed to find the least count of this instrument. We are given that it has 20 divisions per centimeter on your main scale. So main scale, one division is divided into 1 centimeter is divided into 20 parts. Okay, and vernier scale has 50 divisions. 25th division of the vernier scale is equal to, so 25 divisions are equal to 24 main scale divisions. Okay, fine. So what is the least count of the traveling microscope? For those who are going to use the formula of least count as the smallest division on main scale divided by total number of vernier scale divisions, are going to get it wrong. Okay, this is only a special case. If you have seen my videos on vernier caliper, you'll know that this is a very special case in which the nth digit, so basically the nth digit of vernier scale coincides with the n minus 1 division of main scale. Okay, here so is the case, right? 25 coincides with 24, n minus 1. But what is wrong? This n should be the final digit, okay, final digit of your vernier scale. So in this case, it should have been 50 vernier scale division equals 49 main scale division. Only then can you apply this formula. Otherwise, no. Otherwise, you can't. Okay, here we have 25 and 24. Okay, 25 is not the last division on the vernier scale. So what is the least count formula? In general, it is 1 main scale division minus 1 vernier scale division. And we are given that in this case it's not equal. So we are given that remove this, otherwise it might cause confusion. So you get the point, right? We cannot use that formula. So we are given that 25 vernier scale divisions, 25 vernier scale divisions equals 24 main scale divisions. Okay, so what I'll do, I'll express everything in terms of main scale. So 1 vernier scale division, so take 25 to the other side, it will be 24 by 25 main scale divisions, right? So 1 main scale division minus, in place of 1 vernier scale, I'm going to substitute that. Okay, so this will be, take the LCM, 25 minus 24, which is 1, again main scale division divided by 25. Okay, so this is the least count. Now what is 1 main scale division? You can see that on the main scale we have per centimeter 20 divisions. Okay, or the main scale 1 centimeter on the main scale is divided into 20 divisions. So 1 centimeter is divided into 20 divisions. That's the least that you can measure on the main scale, or 1 main scale division. Okay, so 1 centimeter by 20, 1 by 2 is 0.5 and 1 was 0. Okay, so this is 0.05 centimeter. Okay, so your main scale, 1 main scale division is 0.05 centimeter, and that divided by 25. So what do you get? You get 0.01 divided by 5. Again, half of this, I can say this is 10 to the power minus 2, and 0.2 into 10 to the power minus 2, or 0.2 into 10 to the power minus 3, which is, everything is in centimeters. So I think this is the correct answer. We get 2 into, when you solve this, it's 2 into 10 to the power minus 3, which is this, right? And the answer is in centimeters, of course. So this is not the one, option C. Okay, so that's correct. When you apply this formula, you will get a different answer. I think you get this answer, which is incorrect. Okay, remember that this formula is only valid if the nth division of vernier scale coincides with the n minus 1, provided the nth division is the final division of the vernier scale. Okay, here it's 25th, it's the middle division, not the final, which is 50. Okay, so that was the point to remember. This is the general least count formula. It's applicable everywhere, provided main scale division is greater than vernier scale. Anyways, let's not go into the details. Over to the next question. Question 13 and 14. In question 13, we are making some observations with micrometer. Okay, these are the observations. We are supposed to tell what is the reading on this micrometer. Okay, the first observation is that screw moves a distance of 0.5 millimeter in one complete rotation. Okay, so this is nothing but giving us the idea of pitch. Pitch is nothing but the distance traveled, the linear distance actually, in one complete rotation. So which is 0.5 millimeter. Okay, so this observation gives us an idea about the pitch. Total number of circular scale divisions is 50. So number of circular scale divisions is 50. So from here you can find the least count. Least count is basically pitch upon, okay, least count is pitch upon number of circular scale divisions. So pitch is 0.5 divided by circular scale divisions 50. So 0.1 divided by 10, this is 0.01, right, and that is in millimeters, right, 0.1 divided by 10, yes. So that is our least count. 45th division coincides with the pitch scale, so this is while measuring, okay. So will have to use this for circular scale reading, right, coinciding division into least count, right, that. So that will give us the circular scale reading, and the instrument has a negative zero error of this, so negative of this. So that is that also we have to take in account when we are measuring. And finally the main scale reading, okay. So your reading will be main scale reading plus circular scale reading minus zero error, right. This is the general formula for reading: main scale reading, circular scale reading, and minus zero error, okay. So main scale reading is 2.5 millimeter, okay. Then circular scale reading, this coinciding division into least count, which is that 0.01 minus zero error. Minus zero error is this, and zero error is in this case negative, okay. So minus 0.03, okay. So let's do this all at once. So this will be 2.5, this is 0.45, and this will add, right, so 48. So that is 2.5 plus 0.48, 50 and 48 is 98, right. So I think option C should be the correct choice over here, 2.98, okay. So that's the correct choice. So let's move to this question. Here we are given that the kinetic energy, okay, kinetic energy of energy emitted by the light incident on a metal, okay, is lambda. So E is the kinetic energy when light of some wavelength lambda is incident on a particular metal. So to double the kinetic energy, the incident light must have what wavelength, okay. So that is the question. So first of all, we will get kinetic energy E when we use a wavelength lambda. So energy of radiation is this minus the work function, right, of the metal. In the second case, we want to double the kinetic energy. We want 2E. So we'll use the wavelength, some different wavelength, lambda dash or lambda 1, let's say, and we'll have again minus 5, right, same metal, same work function, okay. So now we have to solve this in order to obtain the value of lambda, okay. How can we do that? Actually we don't want this phi, right, we don't want phi. So what we'll do, either we can add or we can subtract, or we will write everything in terms of phi. Phi will be given as, so take phi to the other side, so hc by lambda minus E, and in this case it will be phi hc by lambda 1 minus 2E. Okay, so we can equate this two now because work function of the same metal phi. So hc by lambda 1 minus 2E is equal to hc by lambda minus E. Okay, let's simplify that. We want the value of lambda 1, keep that in mind. So how will we do that? Take this to the other side. So hc by lambda 1 will be, this will be plus 2E, so hc by lambda plus E, right. Now take the LCM, what will happen? We'll get hc by lambda 1 as hc plus E lambda upon lambda, and now finally when you solve for lambda 1, okay, lambda 1 will be hc lambda upon this thing, hc plus E lambda, hc lambda upon hc plus E lambda, hc lambda upon E lambda plus hc. Yeah, option B is correct. Over to the next question. 15 and 16 over here, let's do it quickly. Question 15, we have a boat which is sent across a river with some velocity 8 kilometers per hour. The resultant is 10. So the smarty pants can directly think about this. It's a triangle 6, 8, 10, right? So the correct answer should be option B, 6. Okay, so let's solve it for those who didn't get it. So we are sending a boat with this velocity Now the river will have its own velocity Vr, which we are supposed to find, and the resultant is somewhat like this parallelogram law, and that is the resultant V capital R is given as 10 kilometers per hour. Okay, now we directly know that Vr, so you can use Pythagoras. Actually, you can see that this is a right angle triangle like this. You can take this over here. Okay, so you can use Pythagoras. So that's how we concluded that this should be 6. Okay, so now Vr will be given as this velocity square, the velocity of the river square, plus the velocity of boat square and under root. Okay, so the resultant velocity is 10. It is given, right? We are supposed to find velocity of boat, which is 8. Is it 8? Yeah, 8 square 64, right? Now square on both the sides, this will give us 100 Vr square plus 64. 100 minus 64 is Vr square, which means that 36 is Vr square. And what is 36? 36 is 6 square, so Vr is nothing but 6 kilometers per hour. Okay, so that is the velocity of the river to get the resultant velocity as 10. Okay, now let's come to this one. Here we have a system of pulleys. Okay, you are supposed to assume the ideal condition, neglecting friction and mass of pulley. You are supposed to tell the acceleration of B. Okay, so if you see, this is a system where it is movable pulley, right? Both the acceleration of A and B will not be the same. So you have to use the concept of, we can use anything actually. You can actually directly see it, but I usually use this summation T dot A as 0 to find the acceleration, the relation between acceleration of A and B. Okay, so let us assume that acceleration of A is in the downward direction. So first of all, let us assign tensions here. Suppose the tension is T. So this is the same string, so same tension T, T and T, right? T and T pulling on this string, so it will be 2T, and here also it will be 2T. Okay, and we have mg both down acting in the downward direction. So now we are supposed to equate this to 0 so that we get relation between acceleration of A and B. Okay, so that is the first step. So here if you see T dot A, okay, so here we have 2T dot, so if you see the angle between 2T and A, so we'll assume that B is going up. Yeah, so if A is coming down, B is going up. Yeah, we'll assume this condition. Okay, so if you see 2T and A, acceleration of A are in opposite direction, so cos 180 minus 1. So this is for this block. Let's come to the other block. So summation, right, for this block and this block. So this block, if you see, AB is in the upward direction and T is also in the upward direction, so it's positive cos 0 1 basically. So T and T will get cancelled. Acceleration of B is this acceleration of A, right? Acceleration, twice acceleration of A. Okay, or yeah, we'll write it this way. So this is the relation between acceleration of A and B. Note that they are not equal, right? This is movable pulley. That is why it's happening so. Okay. Now write the equation of motion for block A and block B. So for block A, you can write is going in the downward direction. So mg is greater. mg minus 2t. mg minus 2t is mass into acceleration of A. Both have the same mass. You can note that. Then here for this, it is going in the upward direction. So t minus mg is mass into acceleration of B. Okay. Now we want the relations to be in same acceleration. We want to find acceleration of B, right? So we have this relation. So in place of A, I am substituting acceleration of B. Okay, in place of A, I can write it as acceleration of A is acceleration of B by 2, right? So acceleration of B by 2. And what I'll do, I'll multiply this equation by 2 so that we can cancel it out. 2t minus 2mg plus 2mab. Right, now add this. When you add this and this will get cancelled. This is minus mg, right, and this will be when you add that, this is 2.5 is 2.5, or 5 by 2 mab. M and M will get cancelled, and you can see that AB is minus 2g by 5. Minus sign is coming because we assume the directions to be wrong. Okay, actually directions of A should have been opposite. Okay, direction of B should have been in the downward direction. Okay, anyways, even if the direction is wrong, I think I made a mistake while writing this. Okay, I think it should be 2g by 5. Let me check that. Okay, yes, it is 2g by 5 and option D is correct. Okay, so option D, 2g by 5 is the acceleration of B. This is the standard approach of doing problems of movable pulley. Yeah, so that's from this question. Over to the next set of questions. Question 17 and 18 now. So in question 17 we have an iceberg which is floating on the sea. The density of the sea is given and the density of the ice is also given. Okay, you are supposed to tell what fraction of the total volume the iceberg is above the sea. Okay, so basically why is it floating? It is floating because the upthrust is balancing its weight. Okay, so mg is equal to the upthrust. Okay, now upthrust is given as the immersed volume rho into g. Okay, upthrust is due to the volume which is immersed inside the water. Okay, rho is the density of the liquid. Keep that in mind, and g is acceleration due to gravity. And here the mass of the iceberg can be written as its density. Now this sigma is for solid, write it somewhere. Sigma is for solid and rho is for liquid, right? So the mass of the solid can be written as density of solid into its total volume, right? Density into total volume. So this V is the total volume, VTL, right? And this G and G will get cancelled. Now you can clearly see that sigma by rho will be volume immersed by the total volume. This is the fraction of the volume immersed. Okay, you are supposed to find the volume that is exposed, the fraction of volume above the sea level, So we'll find the volume which is inside the sea level minus the total volume, that is the part that is shown. Okay, so this is sigma is if you see it is 0.92, right? Density of ice 0.92 and density of seawater is given as 1.03. This is volume immersed by Vt. So if you solve this, the answer that you will get is 0.89. Okay, so the volume immersed is 0.89 times the total volume, so 89% roughly. Okay, so 89% of the total volume is immersed. Okay, so this is 89%. So what is the part which is shown? 11%, right? So 11% of the total volume is shown. Okay, let's come to this one. We have two capacitors over here. Excuse me. So each having capacitance of 40 microfarad. Okay, and they are connected in series like this. Okay, so what will be the equivalent? It will be 20. But here's the catch. One capacitor is filled with some dielectric of dielectric constant K. Okay, so initially both of them had capacitance Cc 2020, but now this capacitance will become K times C, right? And this will remain C because there is no dielectric in that one. Okay, now you are supposed to find, no, now you are told that the equivalent capacitance of this system is 24. You are supposed to find the value of dielectric constant. Okay, so the C equivalent in this case is C1 C2 upon C1 plus C2, right? This is the formula for C in series, right? Product upon sum. So first C1 is Kc and C2 is C, and this is Kc plus C, right? So let's take common what is common. Let's take C common in the denominator, and C and C will get cancelled, right? And you have Kc by K plus 1, Kc plus K plus 1, and this value is given to be 24. So 24 is 24, and you can take actually K to the other side. So this is 24, K plus 1 to the other side. Okay, so it will become like this. Okay, now solve for K. 24K plus 24 is equal to, what is this? This is C. C initially was 40. Okay, so 40 into K, right? C is 40. Okay, now 40 minus, so K will become, So if you take this to the other side, that will be 16, I guess. 16 is equal to 24. 16k is equal to 24. Okay, so basically we are solving. So 24 by 16, which is 8 3s are 8 2s are 3 by 2, which is 1.5. So 1.5 is the correct choice over here. Okay, here why does the capacitor becomes K times C? Because capacitance is A epsilon by D, right? When you introduce a dielectric, this epsilon becomes epsilon naught times K. Okay, so initially when there is no dielectric, it's A epsilon naught by D, and when you introduce a dielectric, this epsilon becomes relative epsilon, which is epsilon times K. Okay, so that's why the capacitance becomes K times of C. Okay, and C over here is 40. Okay, and just solve that. The value is given as 24. Solve the equation and obtain the value of K. That's simple. Over to the next question. 19 and 20 over here. Question 19 is a bit lengthy, so we'll do question 20 first and erase off some space for it. So question 20, if the potential at any space is given by this equation, okay, in volts, then the electric field at this point will be, okay, it's very simple. You're just supposed to know the relationship between your potential and your electric field. It's basically dV by dr. Here only x is there, okay, and actually it is gradient, okay, minus dV by dr, and it's actually partial differentiation, and it has ijk component, but here only potential is a function of x, so it will be simply given by this. Okay, so electric field will be given as minus derivative of that, which is 6x, and I cap is there. So you are supposed to find electric field at 103, right? 103. So x coordinate is 1, so just substitute x as 1. It gives 6 I cap, minus 6 I cap, so 6 volts per meter. Okay, it's in standard units. This is in volts and this is meter. So dV by dr, volts per meter, right? So minus 6 I cap. So let's clear off some space for this one, 19th one. And okay. So in question 19, we have a spherical symmetric charge distribution. The charge distribution is as given. So for distances lesser than the radius, capital R is the radius. So for distances lesser than radius, this is the relation. And for distances greater than the radius, life of average YouTuber, so you are supposed to tell what is the electric field at a distance R, at a general distance R. Okay, so let's imagine it. Okay, so what we'll do, we'll consider a segment, okay, at a distance R from the center. Okay, the segment has a thickness dr. Okay, so you know where this is going. This is going towards integration. Okay, so first of all, how will we find electric field? Electric field will find it using the same logic which we use for charge distribution, that integration E dA is q by epsilon naught, right? The flux is equal to sorry, q by epsilon naught. Okay, so now the problem over here is we don't have the charge. Okay, here E and A are simply E and A, they will come out. E is symmetric, right? A symmetric spherical charge distribution. So E and A are for the area element. E and A are in the same direction. Okay, and yeah, area will be basically integration of dA will give you A, and for a particular distance R, E is uniform, spherically uniform. Okay, so basically the relation that you get is this. From here you can easily find the electric field provided you know Q. Now in order to find Q, we are going to use the element, okay, this element which has some charge Q, dQ, which I'll say. So dQ will be given as rho times dV, right? Because your rho is dQ by dV, right? So dQ is given as rho dV. Now rho for distances lesser than the radius, since this element is inside your sphere, it is given as rho naught 3 by 4 minus r by r. And what is dV? V is 4 upon 3 pi r cube. So dV will be, take the derivative, so it will be 4 pi r square. Okay, you can take and verify that, 4 pi r square dr. Okay, so it is 4 pi r square dr. okay, or basically it is the surface area times the thickness. Area is area, volume is area into thickness, right? So area into thickness, okay. So that is our, I shall say that is our charge, okay, on that surface element. So 3 by 4 into r square, I will multiply r square inside, here it will be r cube by capital R, and we have dr, okay. Now what to do, we can integrate this, okay, we'll integrate this from 0 to small r at some random distance at which we are supposed to find the electric field, so that we'll get charge in that region, and from that charge in that region, okay, charge enclosed, right, charge enclosed in our Gaussian region we can find the electric field, right. So we'll integrate this dq from 0 to r. So you can see that rho naught and 4 pi are constant, they will come out of the sign, integration sign. So here we have 3 by 4 r square minus r cube upon capital R dr, right. So you have charge to be given as rho 4 pi, and this will be 0 to r integration, so you can directly write it, okay, no need to write and then substitute the limits, you will get the same answer basically. So 3r square, integration of 3r square will be r cube, okay. If you see r cube, the derivative is 3r square, right, or you can directly take the integration of r square, which is r cube by 3 gets cancelled, okay. And then we have for this one, this will be r to the power 4 by 4 into capital R, okay. Capital R is constant. Now what to do next, this dr will go since we have integrated now. Now just substitute this over here, okay, and that will give you your answer, okay. Let us substitute that. We know that electric field will be, we had the relation EA as Q enclosed upon epsilon naught, right. So E will be Q enclosed, which is this rho naught 4 pi, and we have r cube upon 4 minus r to the power 4 upon 4r, okay. So you can cancel this 4 throughout, and then we have, bring that area down, so epsilon naught is also there, and area 4 pi r square. So pi and pi will also get cancelled. What remains is rho naught 4 epsilon naught, and this r square we can cancel, r square with r cube, and here we'll have power 2. So this is r will remain, and here r square by r, right. Yes, and I think in all the options r is taken common, so let's take r common. Here we'll get 1, and here we'll be left with r, okay, r. So I think that matches with option C, is it? Rho naught r upon 4 epsilon naught 1 minus small r by capital R. Yes, so option C is the correct choice over here. So that's from this question. I hope the approach was simple. We just use integration. The process is the same, the logic is the same for charge distribution, only that the Q enclosed was to be found using integration, okay. So that's from this question. Over to the next question. Question 21 and 22 over here. So in 21 we are told that if the acceleration due to gravity experienced by a point mass at height h from the surface of the earth is same as the acceleration due to gravity due to at depth alpha h, okay, this h is very much small as compared to r, this is very important. So from the earth surface, so at a certain depth alpha h, the gravity, acceleration due to gravity is same as certain height h, okay. So acceleration due to gravity at height h is same as the depth alpha h, okay. Suppose this is the surface of earth, h is very small, then you are supposed to tell the value of alpha. Now g, variation due to height, is given as g into 1 minus 2h by r, and g, variation due to depth, and this is only true if h is pretty much smaller than r, which is the case in the question, okay. So hence you can use this formula, okay, otherwise you have to go by the entire derivation, okay. And g depth is g minus 1 d by r, okay. Now you can easily compare this, these two values are given to be equal in the question. So if you compare this, depth is given as alpha times of h. So you can see that the value of alpha should be equal to 2. Okay, let's come to this one. Here we have pressure P1, density D1 of a diatomic gas. It undergoes an adiabatic process, okay, and its pressure changes to P2 and density to D2. D2 by D1 is given as 32, and you are supposed to tell, of course, now during this process the temperature of the gas will increase, okay. Sorry, excuse me. And so you are supposed to tell the temperature of the gas increases and becomes dash times the temperature, dash times the initial temperature, okay. T2 is what times the initial T1, okay. So we can use the adiabatic relation P1 V1 raised to gamma is equal to P2 V2 raised to gamma. Now you can see that we are given densities D2 by D1 as 32. So density is inversely proportional to volume. Density is mass by volume, right? So mass is constant of the gas. So density is inversely proportional to volume. So here D2 by D1 is 32. So which means V2 by V1 should be 32, or V1 by V2 should be 1 by 32. Okay, is it? Or did I do something wrong? So D2 by D1 is 32. So V2 by V1 should be 1 by 32, and this should be 32. Inverse relation. Okay, so D2 by D1 is 32, then V2 by V1, same relation will be inverse, 1 by 32. Okay, so V1 by V2 is 32. Okay, now we don't want anything in terms of pressure, we want it in terms of temperature. We want T1 is that much times of T2, right? So we can use the relation P is equal to nRT by V. Here the variables are P, T and V. Okay, so in place of P1 we can put T1 by V1. Okay, NR and NR on both the sides will get cancelled, so need not worry about them. And here we have T2 by V2, V2 raised to gamma. Okay, so T1 V1 raised to gamma minus 1, T2 V2 raised to gamma minus 1. T1, so we are supposed to find T2 in terms of T1. So T1 is V1 by V2 raised to gamma minus 1. This will give us T2. Okay, so T2 is this times of T1. Okay, we want a numerical answer for that. So T2 is, if you see V1 by V2, we just found it out to be 32. So 32, that to the power gamma minus 1. Gamma is 7 by 5. So 7 by 5 minus 1, that is, what is that? That is 2 by 5, right? So 2 by 5 of T1. Okay, so this will give you 35 is 2 to the power 5, and this is again 2 by 5, so 5 gets cancelled, and 2 to the power 2, which is 4T1. Okay, simplification, just 32 is 2 to the power 5, 5 and 5 will get cancelled, and 2 to the power 2 is 4. So T2 is 4 times of T1, so T2 is 4 times of T1. Correct answer is 4. Over to the next question. 23 and 24 over here. In question 23, we are supposed to find the current in this circuit. Okay, it might seem as a complex circuit, but it's very simple. Let us consider that the potential over here is A. You can also consider it as 6 and here as 0. Okay, but we'll consider it as A. So here also the potential will be A. Since there is no circuit element, it's just a wire connecting this point to this, same potential will be over here, right? So potential A, potential A. So potential B, here also the potential will be B. Now if you see, all the three resistors are between A and B, A and B, A and B. Okay, so you can draw it like this. So if this is point A and this is point B, Hooker ki city, this is 9 ohms, this is 9 ohms, and this is 9 ohms, right? So all these three are between A and B. So it's not a series combination, it's a parallel combination. So basically in parallel combination, R equivalent, if you have 999, it will be 9 by n, or here in this case this is 3, 9 by 3 resistors. Okay, so that is 3, right, 3 ohms, and I will be given as V by R. V is 6 and R is 2, R equivalent is 2, and this is 2 amperes, so this is 2. Okay, excuse me. Question 24, a closely wounded circular coil of radius this. Okay, we have a circular coil of radius 5 centimeters. This produces a magnetic field is given at the center. Okay, fine. and the number of coils, the number of turns is 100. We are supposed to tell what is the current in the coil. Okay, so the magnetic field is given as mu 0 I upon 2r, right, at the center of a loop. Okay, this is loop and it has some turns, so it is a coil. So into n you have to do, B is given as 37.68 into 10 to the power minus 4. This is the magnetic field at the center. Mu 0 is 4 pi into 10 to the power minus 7. I you are supposed to find, n is 100, okay, upon 2 times r. R is 5 and in centimeters, so convert that to meters. So we have 37.68 into 10 to the power minus 4 into 4 pi into, we'll simplify the powers. Okay, 2 5s are 10 and this can get cancelled, right, and this will be 10 to the power minus 5 and that will be 10 to the power minus 4. Okay, so simplified and into I, which we are supposed to find. 10 to the power minus 4, 10 to the power minus 4 cancels, and 37.68 divided by 4 pi is 12.56. okay, so this is I. So if you see 12 3s is 36, so I think it should be around 3. It will be 3 exactly. So actually if you want to do 12.56 into 3, so that is 36 and 56 3s are 150, so 37 and 56, right, 6 is 18, 150, 168, so 37.68, right. So yeah, so this 3 times is 37.68, so 3 amperes is the current. So answer over here is 3. Okay, yeah, that's your answer. Let's move to the next set of questions. 25 and 26 over here. In question 25 we have two light intensities of 4i and 9i which are interfering on a screen. The phase difference at a point A on the screen is 0 and at point B is pi. Okay, so here when the phase difference is 0, the intensity will be maximum. Constructive interference, this is destructive interference, right. The phase difference is pi. Okay, you are supposed to find the differences in the resultant intensity at A and B. Okay, so the intensity at A will be maximum, right, because the phase difference is 0, and which is given as, if you have two different intensities, it is given like this, under root of I1 I2 the whole square. Okay, so let's find it out. This is at point A, right. So square root of I1 is 4i, so that will be under root 2 root I, and this will give us 3 root I, so that will give us 2 plus 3 5 root I, right, and that squared, so this will give us 25i. This is the intensity at point A. Similarly at point B, minimum intensity is given as I1 minus I2 square root and that whole squared. Okay, so this is again this will be 3 minus 2. We'll take this as I1 and this as I2. Okay, just even if you get minus, that is squared anyways. So 3 minus 2 is 1. So 1 root of I, and that is squared. So which is I. Okay, so you are supposed to find the difference in the intensity at A and B. Okay, so basically it is 25i minus I, which is 24i. So the correct integer over here is 24. Okay, so pretty straightforward, simple question. Here we have a wire of length L. We are going to bend it in a circle. Okay, it is carrying a current of 14 amperes. You are supposed to tell what is the magnetic moment. Actually, in the previous mock test, we did this question in a general way, and we found out the formula that the magnetic moment is simply IL square by 4 pi. Okay, you can use this formula, but you will do it by the general method. Okay, so here 314 centimeters. We are going to bend it in a circle. So basically this length is equal to 2 pi r, right? The length is bent into the circumference. Length is bent into circumference. So L is equal to 2 pi r. So L is 314 and this is 3.14 into 2 is also there, and here r. Okay, so from here we can find r. So this if you see is 100 times, right? This 100 times, yeah. Then 100 by 2 is 50, right? So 50, and this is in centimeters, right? So 50 centimeters is the radius, or we can write it in meters. This is in centimeters, so 0.5 meter, half a meter, right? 50 centimeter, half a meter is the radius, and the magnetic moment is basically given as m is equal to Ia, right? And here we'll have pi r square, area of a circle. I is 14, and this is 3.14, and radius is we can write it as half. Okay, half into half. Okay, this can go with this as 7, this will go with this as 314 is 150, and 14 half is 7. Okay, then 157 into 7, 700, 351, 1050 into 7 is 49, so 1099, and 2 decimal shift, so 10.99, so approximately it's 11. Okay, so 11 ampere meter square. Sometimes it might not be exact, but you have to guess the closest integer. So it's here, it's like 10.99, so almost 11, right? So 2611 is the correct answer. Over to the next set of questions. Question 27 and 28 over here. In question 27, long story short, we have a xy plane as the boundary of separation between two mediums. M1 is the first medium, which has a refractive index of √2, and M2 is the second medium. Okay, it has a refractive index of √3, this is M2, and this is our xy plane. Okay, this is Z positive, so that is the region of M1, Z negative, that is the region of M2. Okay, now some light is along the direction of this P vector and is incident on this plane. Okay, now it is going from, I can say it is going from √2 is 1.4, √3 is 1.7, so it is going from rarer to denser, so bent towards the normal. Okay, so originally it should have gone like this. Okay, so this is the angle of refraction, this is incidence, right? So you are supposed to tell what is the deviation, so this angle. Okay, what is the difference between the angle of incidence in M1 and the angle of refraction in M2. Okay, you are supposed to tell this angle. Okay, so let's begin. What can we do? First of all, let's find the angle of incidence. Okay, from there we can find angle of refraction and then the difference, right? So angle of incidence, how will you find that? We know that our light is along this direction, along the vector P. Okay, and the normal, what is the normal, is along minus k cap direction. Okay, please note that this is z axis. Okay, this is xy plane. Okay, the normal will be along this direction, right, along k cap. Okay, this is along k cap, but we cannot take this one because we want the angle between these two, so we want their tails to be coinciding, right? How do you measure a angle between two vectors? If they are placed this way, you bring their tails together, right? You bring their tails together, so you'll move this vector parallelly so that their tails coincide. Okay, so we want to coincide their tail, so I will take the normal vector as minus k cap. Okay, so what we'll do, we'll find the angle between this p vector and between minus k cap, which is the normal to the xy plane. That will be the angle of incidence, right? If you move this parallelly, okay, you'll get this, like this, right? So this is nothing but angle of incidence. Basically angle of incidence is this, but here also it will make I, right? So I have just shifted this from here to here. Okay, so yeah, so a key point is take minus k cap as your normal. Okay, so let's find out the angle between these two vectors. How do you find angle between two vectors? Cos theta, it's from the definition of dot product. So A dot B upon magnitude of A on magnitude of B. So A is this vector entire, dot B is with this, so no ijk components, so only you have to multiply the k components. So I think this should be minus. Is it? Let me check. Yes, it's minus. Okay, so you'll get minus 5 k cap into minus k cap, so which is k cap into k cap is 1, and this is 5, right? Minus will make it plus, and divided by the magnitude of this vector, we'll find that out, into the magnitude of that is a unit vector, so its magnitude is 1. So let's find the magnitude of this vector. Where can we find? We'll find it over here. So 4, this square, so 4 is 16, 16 into 3 plus 3 square is 9 and root 3 is 3 again, plus 5 square is 25. Okay, so this is 27, 25, 52, 52 and 4800, right? So it's under root 100 or it is 10. Okay, so the magnitude of this vector is 10. So you get cos theta as half, or theta is simply 60 degrees, or this is nothing but angle of incidence, right? Angle between your light and the normal, right? So this is angle of incidence. So angle of incidence is nothing but 60 degrees. Okay, now from angle of incidence you can find the angle of refraction using Snell's law. So let's use Snell's law. Mu2 is refractive index of the first medium. Sine of y, sine of 60 is root 3 by 2. Fine. Sine of this mu2 is root 3. Sine of r we are supposed to find. Okay, so root 3 will get cancelled. We'll have 1 by root 2, right? Sine of r is 1 by root 2, which means r is 45 degrees, right? Sine of 45 is 1 by root 2. So r is 45, I is 60. You are supposed to find the difference between the two, right? The value of difference in the angle of incidence in M2, angle of incidence in M1 it should be, and angle of refraction in M2. Okay, so difference I minus r, which is 15 degrees. Okay, so the correct answer over here is 50. Okay, let's come to question number 28. I hope this approach was simple. And in 28 it's very straightforward question. Here you are given PN junction diode. The potential difference is 0.6 volts. The electric field you are supposed to tell within a region, within the depletion region of 6 micrometer. Okay, so basically if the field is uniform, you can basically write it as the delta V by the distance, okay, by the width. Okay, so delta V is 0.6 volts, and that you divide by 10 to the power minus 6, 6 into 10 to the power minus 6. So this is 0.1 into 10 to the power 6 it will become. So I can write it as 1 into 10 to the power 5, right? And this is standard units, Newton per coulomb, right? It's 0.1, that goes on top as 10 to the power 6, yes. And so the solution over here is 1. Okay, the correct integer will be 1. So let's move to the last two questions for the day. Okay, if you haven't checked out the previous mock test, you can check it after this one. Okay, so let's go to them. Question 29 and 30 over here. Question 30 is your homework questions. You'll let me know the answers of that in the comment section. So let's do question 29. A sound travels in a mixture of helium and hydrogen, 2 moles of helium and some n moles of hydrogen. If the RMS speed of gas molecules is root 2 times the velocity of sound, you are supposed to tell what will be the value of n. Okay, so first of all we have a mixture, so we can find gamma of the mixture. Okay, here also from here we can get the idea of what is gamma from this data, that the RMS value velocity of gas molecules is root 2 times that of sound. So we'll find the gamma mix and by both the relations, and we can then solve equations. Okay, so here gamma mix will be Cp mix by Cv mix, right, of the mixture, right? So basically Cp and Cv will be given as N1 now of the mixture, it will be given as N1 C1. Okay, I shall say Cp1 plus N2 Cp2 upon N1 plus N2. This is for Cp, and similarly for Cv, Cv1 plus N2 Cv2 upon N1 plus N2. So this N1 plus N2 will get cancelled. So finally we have N1 Cp1 plus N2 Cp2 upon N1 Cv1 plus N2 Cv2. Okay, so now Cv, if you see, is given as, so we'll find it differently for hydrogen and helium, right? So for H atom, which is H molecule, I should say H molecule. So for H2, it is a diatomic molecule. So here degrees of freedom is, if you see for diatomic molecule, it is 5, right? 5. So we have x, y, z and 2 rotational, so 5. Okay, we'll neglect the vibrational one. So Cp will be given as, first of all let's find Cv. The formula is Fr by 2. So Fr by 2, so 5R by 2. And Cv, the formula is F plus 2 into R by 2. So you can see that the difference is R, right? Cp minus Cv is R. So here 5 plus 2, 7. So 7R by 2. So these are Cp and Cv for hydrogen atom. So we can say Cp1 and Cv1, whatever. And here let's find Cp and Cv for helium atom. Helium is monoatomic, so F is equal to 3, XYZ, right? No rotational. So Cp will be, so Cv first of all, Fr by 2, which is 3R by 2, and here we have F plus 2 into R by 2. That will give us F plus 2, 5, right? So 5R by 2. So we have Cp1, Cp2, Cv1, Cv2. Let's substitute them. N1 is, let's take N1 to be hydrogen, okay? So N moles of hydrogen. So N Cp1 for hydrogen we have 7R by 2, okay? Plus for helium we have 2 moles of helium. So 2 into Cp2, which is Fr by 2, okay? Then we have N1 again, which is N Cv1 for hydrogen. So 1 is for hydrogen, Fr by 2, 5R by 2, plus N2, which is 2, and Cv2, which is for helium, 3R by 2. Okay, let's solve this now. Actually we can cancel R by 2 throughout. So R by 2, R by 2, R by 2, R by 2, right? So we'll have 7n plus 10. So in the numerator we have 7n plus 10, and in the denominator we have 5n plus 6, right? So this is gamma of the mixture. Now gamma of the mixture can be found out using one more formula. Since we are given, not formula actually, the relation that we are given, RMS of velocity of the gas molecules is equal to that of the sound. Okay, so root 2 times, so RMS velocity is root 2 times the velocity of sound. So RMS velocity is given as under root 3 RT by m, right? This is the formula for RMS velocity, and velocity of sound is gamma RT by m, right? Gamma RT by m. Here gamma is the gamma of the mixture, right? So we can cancel RT by m, right? So gamma will be, this is gamma of mixture, right? Root of gamma of mixture. So when you square it, gamma of the mixture is 3 by 2. Okay, let's substitute that over here and let's solve it. So 3 by 2 is 7n by 10. Actually I can just, this is equal to 3 by 2. Okay, so 2 into that, 14n plus 20 is equal to 3 times this, 3 times, that is 15n plus 6 3 is 18. So this will be 15 minus 14n. So here you will get n and here you will get 2. Okay, 20 minus 18, 2. So the correct answer over here, the value of n is 2. Okay, yeah, so that's from this question and that's from today's video. I hope you enjoyed it. If you did enjoy it, smash that like button. Next video coming next week. Okay, so yeah, that's about it, and you can check out the playlist in the description of this video. You can check out the previous mock test, and do let me know how was this and how well you answered and all of that. I'll see you soon in the next video. Till then, keep enjoying physics. And by the way, for the maths and the chemistry section of this paper, you can refer to the 29 July morning shift paper of 2022. Yeah, that's all from me. Keep enjoying physics.